Hi, I'm Nicodem and this is the robot arm that I regret building, and I will tell you why in this video. And now, give me the ball. Thank you. That's one of these projects that I was super excited to work on, and I spent a lot of time designing to make sure that everything fits perfectly. And there is a lot of things I truly love about this robot, like plenty of bearings that I used or the fact that it works so smoothly. Also my gripper design that I made at the very end, well, it works pretty well. The downside is, I started this project a few years ago and it took way too much time. But I kept all the footage, so let's go back in time and see how it started. It's year 2022, people are still using Enders and are quite happy with them. At night I'm printing a big part for this robot arm, it took 13.5 hours. Something that these days in 2025 you can print in just 4.5 hours. Right after printing I started the assembly, and after that there was nothing. I forgot about this project and left it unfinished. There was void for about 3 years. But I kept the parts and did not forget.
This project spent, I don't know, maybe even 3 years in a box, and I kind of almost forgot about it. I spent a lot of time on it and I don't want to waste it, so let's build the robot arm.
I spent plenty of hours in Fusion 360 to design this robot arm, but once you start assembly you realize that it was all worth it when everything fits so perfectly. Every single screw goes in place without any problem. That's a really good feeling. The base was probably the most over-engineered part of this project, as I used 2 truss bearings and 2 ball bearings to hold in place this bevel gear, but I'm happy I did because it works very well. I also used over 2608 bearings in the whole robot to make sure that everything runs smoothly and is also strong enough.
The biggest problem is that some of the parts are pretty similar, like for example these arms for the motors. These parts are exactly the same, just the length is a bit different, and it does matter. Adding some features on the part itself, like little dots or numbers so that you can distinguish between them, is a good idea, which I didn't do, and I will probably update the design. So here we have 85, the shorter one on the left.
The biggest problem of this design is that some parts are huge and you need a really big printer, so these parts were printed on Snapmaker 2.0 and Snapmaker Artisan, as you cannot really fit them on any Bumblebee printer, and if you would like to separate them and then join together, that would be just too weak.
Now that I see it assembled, I truly regret not building it earlier. It's so cool. So cool. This will be a lot of fun to program and get to work, assuming it will work.
I paid a lot of attention to all the tolerances and making sure that everything will work together smoothly. I used plenty of bearings in the whole design, and I think it was worth it because assembly was very smooth and I pretty much didn't have to redesign most of the parts. I had a problem with one of the gears that was driving the base of the motor. It was a bit too thick, and once attached to the motor it was hard to put it in place, so I had to make it a little bit smaller. But even this huge gearing works just perfectly fine and is so smooth. When it comes to how it works, despite being 3D printed, I think it works great. It's very smooth, it's quite sturdy. I don't have it attached to the base right now, to the table. But even though it's all just 3D printed plastic parts, it's very strong because everything is quite thick, and I used very strong settings for 3D printing with multiple perimeters and a lot of infill. So that worked great, and I do not regret using 3D printing at all for this project. But I do regret using the motors that I used for this project. Here I was complaining for like 5 minutes to the camera about not being able to use this motor with the Arduino. I eventually did, but there is pretty much no help you can find on the internet at all. Even on Discord, on internet forums, it looks like no one really knows how to properly use these motors. And I had a lot of problems to control the position, but also... And now you will hear another problem. The noise. This motor is loud even though nothing's happening. The KP, KD values are not even set yet. And it's already like trying to adjust for something and this making this weird noise. Why? I have no idea. How to fix it? I have no idea. The internet does not know, but a lot of people face the very same problem. Anyway, The motor now works if I set it to some position and then change the KP. It should move. And it does work, as you can see it's very springy, so we can add some KD and now it should not be that springy. Oh great, even the tripod does not want to work anymore. I spent like 3 hours to get the joystick to work with the motor and look how terrible it is. It's It works. And it is finally very responsive. Can you see it? That is so cool. Progress. I don't like being limited when building my robot arm, but I like being safe when doing that. And I know that not everybody is building robot arms at home, but everybody is browsing the internet. That's why I would like to introduce you to the sponsor of this video, Surfshark VPN. A VPN or virtual private network is like putting your internet traffic in an invisible box so that no one can see what you are browsing, not even hackers, advertisers or your internet service provider. By the way, in some cases your internet service provider may see what servers you are connecting to, and by that they know what sites you are browsing, but you can just open the Surfshark app, click connect, and now they don't. With Surfshark VPN you are not limited by any streaming service because you can just easily change your location and access content that is not visible in your country. They have apps for Android, Apple, Windows, Linux, browser extensions, you can even install it on Apple TV and Fire TV, and yes, you can use it on multiple devices within a single subscription. I just found out that you can also install it on the Raspberry Pi or even directly on your router to protect all the devices within your home. That's pretty cool. Surfshark also offers an antivirus that protects your devices and a private ad-free internet search. Go to surfshark.com/Bartnik or check out the link in the description. There is a 30-day money-back guarantee, so there is no risk in trying it out. Thanks a lot to Surfshark for sponsoring, and now we go back to the robot arm. Did I just broke something? Not yet. Every single motor was working, but I had to combine it all together and upgrade the controller so that I can connect another motor, and I soldered a simple header for that. The controller is a simple PCB that I made at home with a CNC machine, and there is Arduino solder to that. It's already a few years old but still works fine, and there are no signs on the copper that it's that old actually. I also had to make custom cables for the motors to connect them to a power distribution PCB, also made at home by the way, and it worked fine. To test the arm I have been using my Windows computer and that was fine, but for the final version I prefer to have it running on a Raspberry Pi, so I combined the Raspberry Pi with all the electronics on a small plate, fixed everything with screws, and now I don't need my computer to control the arm. It's pretty handy. Yesterday I moved with this project quite a lot. And this is a very weird angle of the camera. That's much better. I still don't have the inverse kinematic equations, and controlling with a pad, it's not really easy. I mean, it moves in two axes at the same time, even when you want to move it only in a single axis, because of how this thing is designed, which is totally my fault. But I'm not gonna give up. I mean, look at all that. That's like, you know, a few days of printing and a lot of work, so I just have to move forward, I guess. Look at the cool thing about this robot. Because you can easily adjust the KP and KD parameters of the motors, you can define how springy they are and the force that is used when you are actually moving the motors. So as you can see, it's very springy, but it also goes back to its position, and that's not just the flex of 3D printed parts, it's actually the motors. And because of that, it's a great collaborative robot, so you can, for example, work next to it, and even if it bumps into you, well, it's not gonna harm you. I've written now a simple Python script that extends what I've already done, and now with a press of a button I can save a specific position. So let's say I will move right here and lift the robot a little bit, and I can save the position with the one button. Then let's say I want to move here, one, and I don't know, maybe a little bit up, one. And now I should just press a button and it should work in a loop. How it will work? I have no idea. It might be 2, not 3. 2. Oh no. Okay. It shouldn't work like this. I think the delay between steps is definitely too small. And second thing, it is going from one position to another at full speed, which we don't want to do. Okay, let's try again with hopefully fixed code. Let's save number 1. And then we go to like... Yes! It is working! Once the arm started working and moving, I decided that, well, we cannot really call it a robot arm without a gripper, so I have to design a gripper. In the morning I did this quick drawing, and right after that started designing, and it took basically like the whole day, but finally the gripper is ready. And this is definitely the best gripper that I've ever designed. So far I designed like 3, one of them for the Mini Mars rover that was also an inspiration for this one, but I fixed all the problems with this gripper. And this one is a lot bigger, a lot more robust. I also used this big digital servo with metal gearing inside to drive it, and that should be a good choice in my opinion. Just recently, Alego, a company making 3D printers, reached out to me and asked if I would like to use their resin printers in my projects. And I do not have almost any experience with resin printing at all, so I thought, yes, of course, let's learn how 3D printing with resin works. And I decided to print this gripper with a resin printer. It was a lot of fun to go through a new manufacturing process that I'm not familiar with. Resin is a bit messy, but thanks to the cleaning station and curing station, it's way easier to post-process your prints. Also, the printer that I got, the Saturn 4 Ultra, is really big, so I was able to easily fit all the gripper parts on a single bed. And a huge plus of a resin printer is that your printing time depends only on the Z height, how tall the object is, because the whole table is displayed at once with the display that is underneath the table. So basically it makes the most sense to just fill your entire bed with parts that you want to print, because then printing is the most efficient. And once again, putting a lot of time into design in Fusion 360 was worth it, because the assembly of the gripper was very easy. I also printed TPU pads on a Bumbleup printer that I added here at the end of the gripper to make the gripper more grippy. I don't know if that's a word, but let's pretend it is. I will put my gripper design on Etsy in case you want to use it in your projects as well. Link is in the description. Something's wrong. Okay, I think I fixed the problem. Does it move now? Yes. And can I move the servo? No. Oh no, of course. This cable was one of the things that you buy online when ordering other parts, with the hope that, you know, at some point it will be useful. Well, it is now. Here it is working. That is so cool. Now if I grab a ball, it can hold the ball and it can drop it. So you can say, yeah, it's so cool, it is working, but it wasn't working exactly as I wanted it to, and there were still problems with the motors. Problems that fortunately I was able to solve in the end. I found the problem in the Arduino code, I fixed that, and then I was able to precisely control the position of the motors. They were still making weird noises, but at least they were working as I wanted them to. But there was a problem that's not an easy fix, and that is the way the arm is designed with the motors in the back and the linkage system. At least I know how to design a better arm in the future. I broke the part of the arm during testing, but there is progress finally, and I fixed the biggest problem with the motors. Now they most likely move as they should, but I need to replace this broken part. Once again, something is really trying to move too fast. I have to fix it in the code, but firstly I need to find a way to stop this robot. Okay, that might be easy. Yeah. Okay, the path is saved. The ball goes back here, and now I press number 2. And I just watch it perfectly navigating and grabbing the ball. Yeah, almost. Yes! Yes, it worked! Grab the ball and drop it. Yes! Such a simple task. But yeah, I'm happy to see it working. I got it to work yesterday, but it wasn't working perfectly, and I changed a few things since yesterday. I built these small Lego constructions to hold the ball in place, and I think now, well, first thing, it will be faster, it should be smoother, and I hope it will be able to pick the ball perfectly, but I didn't test it yet, so now I just press 2, and we see what happens. Oh, that was too fast. I'm kind of tired of this thing almost breaking my fingers. The geometry is wrong, I did it wrong, it's totally my fault, but I learned a lot while building this robot arm, and I want to use this knowledge and build another one soon, this time with NEMA 17 or 23 stepper motors, slightly smaller but still all 3D printed. If you don't want to miss it, subscribe now to my YouTube channel. Thank you very much for watching this one, and I will see you in the next video. Bye!